Okay, so first let's go with some optional views. Right, so this will be items that are good information to have and to understand the process. So I go back and decide to add a sheet. Yeah, it puts it in between, so I can drag and drop that one. So maybe that becomes sheet 1A or 1-1, something along those lines. I think they end up putting parentheses when they do their sequence. All right, so one of the things I would like to have in my view, let's go ahead and bring in the isometric view for the crank assembly. Actually, we need the front view. Let's go with that one and accept it, and we'll make it the dynamic view. And size-wise, let's see what it looks like 1-to-1. A little on the large side, but we'll go with it just for to be able to put the clarity in there. All right, so I go over to drawing, and we used the break view on the last one, and so these have really good applications. They just don't come up that often. So let's go with the alternate position. If I make a new configuration for the alternate position for dynamic, should open up the part, and I can do a free drag to another location and then hit OK. So it's going to update, and it shows me the preview, and might have got that a little far over. All right, but you get the idea of this is kind of the intended movement from here to here. Or I could create an additional configuration that says it starts here and goes to there if it's not able to move. If we want to stay with the static and go from a minus, or we did it at 135 off the horizontal. If I wanted one that was 45, pretty much a little more less critical than that, I could add that as a configuration and then build it into the mix. Staying with this, we've done some section views. So an auxiliary view, this is going to get kind of messy. So let's make it a little bit smaller. We'll go back to the half. And an auxiliary view then would be picking off of that face so that you can see in the direction of the arm. All right, and that is aligned. So if I need to break any of the alignments, we will right-click on the view, look at its alignment, and then break the alignment, and I can rough position it a little bit easier. Now, I don't know that the broken out section is going to help me all that much here, but usually we would draw, if I don't have something drawn, it will ask me for it. So let's go along that line, and we'll do something like that and just draw a circle. A lot of times I'll use a spline so it has kind of a weird shape to it. And then we can create our broken out section. The section scope, auto hatching, exclude fasteners. I don't want any components. The depth, if we're on that face, I don't have the side view. Otherwise, we could pick from the side view going to like that face or to one of the other faces. Don't know that it'll let me do that. I might let me do the edge. All right, so if I preview it, it shows that that's removed out. I can't quite tell if it, nah, don't think it did it on the other view, but so we went 32 millimeters. I can remove that and then adjust it back or back and forth to get a different view of it. What else do we have? We did the break view, a crop view. I don't know that that's going to be very helpful here. maybe we'll go ahead and create a projected view. And then crop view is going to be kind of the same. Let's go into the spline on this one, and I'll take a weird kind of shape and use that to form the crop view. All right, so I can say I don't need all the rest of that. I really just want to focus. It's not really a detail. It kind of has a different, maybe a different feel for it. We can go to a custom scale and do 1:1. And where the detail view kind of gets aligned, this doesn't necessarily maintain the same result. All right, so that one did go with the alignment, and the detail view is free. All right, so one I haven't used was the relative view, defined by two orthogonal faces or planes in their respective orientations. Yeah, I'm gonna have to play with that one. The removed section shows slices of the model at selected locations, so we can break it into pieces. I expect that those sections, it's looking at edges. I don't really see anything in an opposed edge. Don't really have anything. Might be able to do the hidden view on the through holes. We'll hold off on that one, but it should break it into intermediate levels. All right, so for our geometry, then that pretty much covers it. So we'll need to look a little more into the remove, the relative, and that would give me some homework to do. So let's see. We can sketch. We have our sketch tools. The evaluation. We did the alt position. And we can move those guys around. All right, so on the tolerances then, comes back to when we start thinking about fits. If I want this to be a press fit, and I usually think of these in terms of inches to run my tolerances, so I'm sure I will get a decimal place off somewhere here. So 10 millimeters would be designed 10 millimeters on the shaft, 10 millimeters on the bore is a line-to-line fit. There's no interference, there's no assumed clearance there. So we want to utilize our tolerance zones by looking at, do I want a limit dimension? Would I prefer to have a bilateral? We could, if we're going the GD&T route, we could go to basic. So I think from a generic standpoint, let's go with the limit and see what that does. 10, like I said, would be a slip fit, and well, a transitional fit. It wouldn't necessarily be a press fit, but it wouldn't be a slip fit. So plus side, I wouldn't want on the maximum material condition. On a hole, it's going to be the lower number, and on the shaft, it would be the higher number, more material, maximum material conditions. So if we were to go 0.1 would be about 4 thousandths. That's a pretty heavy duty press. So 4 tenths would be 0.01, and so we want to be kind of somewhere in that mix of probably 0.02 on a minus. All right, so I may have to switch over to inch and visual to be able to fully visualize this. So all right, so our geometry says that this is now something that we would want to ream or bore to a little bit under size. Then when we jump over to our 10 millimeter, right on this side, it's going to be a little bit oversized. And so we need to go to its limit dimension and say that it's plus 0.02, so about 8/10, which would be a maximum press of about 1,000th. All right, just roughly running the numbers, which would be, depending on the material, a fairly substantial press. On the other side is the clearances. Now, when we go back into the assembly and actually try to look at these, we're going to see that this is a line-to-line drawing. If I build in those tolerances, um, they can there are other downstream effects. So on one side of this guy is the plus 0.02. On the clearance side, let's see, if I went to say 1/1000th, that would be about, or half of a 0.05 millimeters, that would be a clearance of about 995. That would be a clearance of about 2/1000ths. All right, so that's going to spin free, but there's no restraint on that guy. So would probably need the same thing on this side so that it can spin. All right, so these are our first pass kind of deals. And like I said, it was whatever system of units you're used to working in, probably should stay in that to do the tolerances and not end up fighting these. So we have that first pass. I would really like to see if there were any issues. And actually, I should have saved that. So let's Alt Tab, or is it Control Tab? All right, let's just go to the window, and we'll switch back to, yeah, it was Control Tab, and make sure that this gets saved. And, oh, I guess I did not save it, so I was living dangerously. Let's make sure that it gets saved. And then we'll go Control Tab back to our, no, we don't need the pin. One more time. All right, so we're in the alternate position, or we're in the default. We can see the alternate position that we created from the drawing. We also have the dynamic. If I was to move the dynamic, I would expect that when I get back to the to that assembly drawing on sheet 1-1, that this side would move, but the alternate position would stay in where it was at. All right, so in our evaluate, we haven't really looked at mass too much, so let's go to the evaluate tools, and we have interference detection, clearance detection, measure, and our mass properties. So since I haven't added anything, I believe it still defaults to water, and we can look for a center of mass, we can look for those types of things, but initially I want to do interference detection. Once we add materials and we go a little further on the properties, then we'll take a look at those items. So the crank assembly, let's calculate, and no interferences. That also means that when I do a clearance verification, we go to, let's just say, those two items, and check clearance between, and what are we doing here? Let's go ahead and calculate clearance 1 is coincident or interfering. So that tells me that I'm at that line to line. I have not built in any tolerances or gap tolerances. On the one side, that has the benefit that if I go in and start to do a simulation that places loads on these, it doesn't have to calculate across that gap. So it's still a manipulating, juggling numbers thing to make all of this work. All right, so those give me my my two starter I do not have any gross interferences and I do not have any gross clearances, otherwise it would return the gaps, or it would tell me how much overlap or show the overlap in the mix. All right, so one of the things we can do, and one of the reasons I wait to kind of define, and I'm happy with my geometry, like I said, is if these are loose and one side goes light and the other side goes heavy, that would also affect that this is spinning, that's a press. Then looking at this, I need to go back and decide which one of these is going to be a clearance and which one's going to be the press, because on the drawing, if I'm going to press in on that side and have it remain stationary, then the other side's going to have to be clearance. That's also going to affect the assembly process of the parts. Now on these two, it might not, it probably will not hurt anything if both of these were to spin. But on the crank and the follower, I'm pretty sure I did not place a tolerance on those. So when I talk about the iterative process and thinking through the steps on my mechanical design, I'm at that stage where I'm putting the eyes on. Have I made good choices, and do I need to add something else? All right, so as far as materials, let's stay on task here. I can go back to my materials, and they said that this was an aluminum alloy. So let's edit the material. I'm going to go ahead and adjust my favorites. I'm not doing much in the way of cast iron, cast alloy steel, brass, copper, occasionally nickel, but not very often, not too often on rubber, not enough to really leave it in the favorites. All right, so if I remove those out, we'll see if there's a 2024. All right, so we select and add, and then I'm going to move it up on the list since I'm going to be selecting a lot of it. But really, what we probably use the most of in industry is occasionally some 5052 and mostly 6061 as a preferred alloy. Okay, and then if I close that, now when I select, I'm going to be able to go 2024, expand out, and we keep going down through the list. And I'm pretty sure that it made 2024 everything, so the pin long, so those two should be the same. 2024, we'll have to double check against the drawings. The pin short, get back to that. Now, one of the problems with the aluminum is if there is any kind of heat or dirt, lack of lubrication in those joints, that you can pretty much guarantee it's going to gall up and it's going to seize. So there's going to be some assembly issue with those guys. So I'll get back into view, make sure that we're selecting. All right, so 2024 T4, the actual condition of the material, and everything was 2024. So typically the 20 or the 2000 series is a more ductile, which means that it's going to gall or seize even more than I would expect with the 6061. So this is where the properties of materials comes in, and we need to be aware of some of those things that will affect the ultimate use of this part. So what we'd want to look at is possibly making the pins out of a steel or stainless steel and pressing a bronze bushing in. Again, we don't really have a full specification that says this many RPM. It's going to perform these functions. So that being an unknown, we'll add that to our list of questions for the next design review. So let's go to the file properties, and we'll keep these on the basic side. All right, so I'm not going to worry about the custom properties just yet. Well, this is the custom file, but I mean, we're not going to go into the custom properties on the task pane. All right, so I would like to have a part number, and that is where we're going to, that looks like a 0A4 -32. And we can put a revision is revision A, and our material will pick up the material, so it's going to refer back to what we put in the list. If we go to mass or to the weight, then we're looking at that as a possibility. All right, so I'm going to have to pretty much reproduce this for each of the parts because it did not build it into the assembly. So I'm going to do part number for all of these, but I'm not going to worry about the rest of this. Maybe part number and material. But just to give you an idea of the process. We save that, and what the real function of the custom properties is to have that built in. So interesting that the part number didn't come across, but everything else did. So I would have to check that. All right, so if this shows up in a yellow box that says go ahead and create, that is where we're going to go into the custom properties and the property tab builder and create our interface, build those out, and have that as an option. But for this, and just at the starter beginner level, being able to go into the file properties, recognize that these are the custom properties. The configuration properties, we didn't create configurations in this, but I would probably separate. It might, I'd have to make that matrix of the configuration would definitely be a part number type deal. There could be different materials based on the part numbers, and that would affect the weights between them. So a good portion of this might end up in the configuration properties as well. And then the property summary, we haven't really created anything in that list. We make sure to save that. And when I close it, we can control tab back to the drawing, and should see at least a couple of those come in revision A. Let's see, we need to do a rebuild. It doesn't look like my material came across either. All right, so, let's go in where there would actually be some material. There it is. All right, so what I didn't do and what I do on most of mine is, since we're in metric, I would build in as a field that this is grams, and that grams, kilograms, pounds, ounces, whatever, would build that into the weight, so it makes more sense than, wow, 203 pounds, that's huge. Not really. Okay, so we opened that one from the assembly. I can also go back through at the part level and open. And when I get to its properties, the material has been set. And I need to find the list. So when I am looking at this list, I'll have the, now those look like O's instead of zeros. So whichever one you decide. And we will add that to the group. So the property then is the part number, and we'll go A4-33, and it looks like they're staying consistent on those. So we'll go ahead and highlight, Control C, and that way on the next one I can just Control V it. And material is going to be a property of the file. Make sure to save that. All right, we'll go to the next one while it updates. We can pick any of the views and open file properties, part number, And the coupler then is 35. Oh, would help to tell it what I'm doing. So part number and 35. And the material and the material. And OK, save it, close it, let it update. All right, so we can go through these fairly quick and add the properties without too much difficulty. Where it becomes a bit more of a challenge is when we have a lot. Part number, so I don't think it liked me overwriting that is what it was barking at. So Control V, 34, material, and material. And make sure to save it, close it, and we'll go to the last of the pins. And the pins have our PS1 100, and wow, they really lost their minds on that one. So, well, we'll go with those, but yeah, I think there was would be questioning why those aren't a little more consistent. So, which one am I in? The long, so this is P16-H17. So kind of get the 17 as the length, maybe building in. That's one of the always the challenges is coming up with a part numbering scheme that kind of fills all of those requirements, checks all those boxes. All right, so we'll go back in, open up the last one. Oops, I opened up the options. That popped up on the other screen, so let's go to the add-ins. Nope, not the add-ins. We'll go to the file properties. Okay, I've hit everything but. All right, so part number. And this one is going to be the PS1-100. And the material. And the material. All right, they're save and hit OK. All right, so that one has been updated. We have the alloy. The part number does not look to have made it into my list, so that would be something I would want to consider for my drawing template, for my sheet format, my drawing template, since I have not included that. The mix of description, part number, the drawing, and the actual components. So there's always that mix, and when you start using a template is when you find, hey, that would be really nice if that showed up. All right, so we'll go ahead and finish this one out here, and the next videos we'll start to take a look at the manufacturing process.